Okay. Uh,
Is it visible, teacher?
no, I cannot see. It's not on the screen. Oh, now it's on the screen. Yeah. Maybe it takes some time. Yes.
Done, teacher.
Yeah. Okay. HCA plus H2O become Ca become Ca2 plus become Ca2 plus and then plus OH. So Ca2 plus and then so here Ca2 plus and then plus OH minus, yeah, correct. Yes, correct. Yes, correct. Yes, Felicia. Correct. And state the role of water in the reaction with calcium. Let me ask to let me ask to Patrick's. Patrick's already done. Yes, Patrick's not yet. State the role of water in the reaction with calcium. Patrick's.
Uh, is it to make calcium hydroxide and hydrogen? I don't know.
If it is make hydroxide, then what is the use of the water? To
Oxidize.
oxi- oxidize.
Ox-
Okay. Oxidize what?
Calcium.
Oxidize the calcium, right? So oxidation of the calcium. Okay, and then now uh, correct is correct, Patrix. And then now this one D. Write an equation to show the process that occurs when first initial energy of calcium is measured. So it is from calcium gas become calcium positive ion gas plus one electron. And then so this one calcium gas become calcium one positive, it is gas, and then plus one electron. Okay. E. State and explain the trend in the first ionization energy of group 2 elements from magnesium to barium. Let me ask to Bavia.
Teacher, the trend is that the ionization energy decreases as we go down the group.
Yes.
And the explanation is when you go down the group, there are more electrons and protons, so there will be more electron shares.
Yes.
So that means a higher shielding effect,
Yes.
and the effective nuclear charge would decrease.
Yes.
So the and ionization energy also decreases.
Yes. Correct. Fully correct. Now question number 2. This question is about elements in period 3 of the periodic table. State the element in period 3 that has the highest melting point. The highest melting point. Let me ask to Brian Chipto.
Yes, teacher.
Yeah. What is the element in period 3 that has the highest melting point?
Mm, is it silicon?
Yes. Silicon. Why is it silicon?
Uh, because it has a very strong covalent bond, thus needing a very high amount of energy to break the bonds.
It has covalent bond. Phosphorus also has covalent bond, but it does not have the highest melting point. Only silicon.
Mm, is it because it has the strongest covalent bond?
The strongest,
Covalent bond.
strongest covalent bond. Uh, what does it mean by strongest covalent bond, Brian? In grade 9, we learn only covalent bond is only one. There is no weak, there is no strong. What makes the covalent bond become strong?
Because I don't know, teacher.
Uh,
All I
it
know
should
is it has a very strong covalent bond.
it has stronger bond. It is not only stronger bond, Brian. It has the giant covalent structure. We know
Oh,
covalent
okay.
bonding. There are two structure. One is simple molecular. One is giant covalent. This this silicon has giant covalent structure. And then B, state the element in period 3 that has the highest first emission energy. Explain your answer. Let me ask to Sherry. Hello, Sherry.
Argon because the largest of proton.
Yes, Sherry.
Uh, the element is argon because it
Mhm.
has the largest number of proton.
Because it has the
Largest number of proton.
okay, that's number of proton. Okay, that's correct. Okay, now next, suggest the element in period 3 that has the highest electronegative value. Highest electronegative value. Let me ask to Clarabella.
Maybe chlorine, teacher.
Chlorine. Why is it chlorine? Why not argon?
I don't know, teacher.
No, you know Clarabella. But why is it chlorine, not argon? Because because argon is a noble gas. It never make a molecule. While chlorine is it has the highest electronegative because highest it has the second highest number of proton and electron compared to argon. And chlorine can make a molecule or compound. And then number 3. Number 3, a naturally occurring sample of element boron has the relative atomic mass 10.8. This is a calculation, not difficult calculation, simple calculation. And then this one, calculate the percentage abundance of boron 10 in this naturally occurring sample of boron. So let me ask to Eric, can you solve this
Teacher, I'm
one?
still counting. Yeah, I'm counting.
Yes, using algebra, Eric.
Is it 20,
The
teacher? 20%.
20%, correct, 20%. Okay, number 2, state in terms of fundamental particles why isotopes boron 10 and boron 11 have the similar chemical reactions. Let me ask to Hardy, why the isotopes boron 10 and boron 11 they have similar chemical reactions. Yes, Hardy, are you there, Hardy?
Yes, teacher.
Yeah. What is the reason that boron 10 and boron 11 they have similar chemical reactions?
Same number of electrons.
Yeah, same number of electrons. Um, what subatomic particles in an atom that responsible for the chemical properties? Hardy, can you help? Can you help to answer? What is the subatomic particle of an atom that responsible for chemical properties? Yeah, it is the electron. Electron is the one that responsible for the chemical property of chemical property of an atom or of an element. Okay, and then now next number. Complete table 2 by suggesting the value for the third ionization energy of boron. This is empty. First, second, and then third, and then there is fourth. Write an equation to C. So C, number C first. So let me ask from Kimberly.
I don't know how, teacher.
You make this one boron. You have to refer to the data booklet. Refer to the data booklet. Boron element boron. Is there any boron element? Where is boron? Okay, now this one, boron is around 3660, and then the second one, so the third one is come, it is 3660 Kimberly, because
Yes.
in this one we have to use data booklet. The only thing that we have is data booklet. And then D, equation for the process that occurs when second ionization energy of boron is measured. Maybe Lawrence. Hello,
Yes,
Lawrence. Yeah.
yes.
Can you help us to answer D? Write an equation to show the process that occurs when second ionization energy of boron is measured. Include state symbols in your equation.
I'm not sure how, teacher.
Yeah. You want to do annotation?
Uh, how do I ask for annotation?
Second ionization energy. You know already the first, and now question is asking for the second.
This one. Wait, teacher. I don't really know how to do it, teacher. Hello?
Yes?
Yeah, I don't really know how to do it.
Or you don't really know how to do it. Okay,
Yeah.
the second ionization energy of the boron, this one, is we 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 know already that if first ionization energy is boron become boron plus plus E minus. This is called as the first. And then for the second, of course, boron plus become boron 2 plus plus E minus plus E. So plus E minus, it is called as the second ionization energy of boron. So this one, how this is the process. So first is 79799. Okay, so the energy is 799, and then the second one is 2420. So what is the total? The total is 799 plus 2420, 2420 plus 799. So this is the method. Okay, so around 2000, uh, 3000, 3210, 219 kilojoule per mole. Okay, Lawrence. Okay, now yeah, now let me ask Michelle for the next question. Explain why the second ionization energy of boron is higher than the first. Michelle? Hello, Michelle?
Yes, teacher.
Yeah. Why is the second ionization energy of boron is higher than the first ionization energy of boron?
Um, it's because there are more electrons that have to be removed.
More electrons
Have to be removed.
has to be removed, and then
So it take so the energy required is more.
yeah, if more electrons to be removed, uh, uh, it is quite not complete, Michelle. So one electron has been removed, so the second electron, which is in the outermost shell, has strong has stronger nuclear charge to the towards the proton, towards the nucleus. That makes the energy required to remove the second electron from the outermost shell requires more energy. Okay, now let's see this one. Nickel. Nickel is a metal with high melting point. State the block of the periodic table that contains nickel. Let me ask to Narkis. What is the block in the periodic table that contains nickel?
Block D.
Yes, block D. And then explain in terms of its structure and bonding why nickel has high melting point. Let me ask to Natasha.
Yes, teacher.
Yes, Natasha.
Um, nickel. Nickel has a strong bond,
Nickel has strong bond. No.
and is nickel in solid state because it's a metal?
Yeah, nickel is solid state at room temperature. What makes nickel solid state at room temperature?
Is this the ionic bonding?
No, no. Nickel, in this one, nickel is as an element, not nickel as part of compound.
Metallic bonding?
It has metallic bonding. And then what is the structure?
Solid?
Yeah,
Solid structure? Hard structure?
hard structure. No, there is. We do not study that one. Hard structure. The term is not hard structure.
Solid?
That is the state at room temperature, solid, but not the structure.
Regular structure?
Yeah,
Regular structure?
regular structure. That is the shape. That's the pattern, regular pattern, but not the structure. Okay, Natasha. Ionic bonding has giant ionic lattice structure. It is called as structure. And covalent bonding, there are two structures. One is simple molecular, one is giant covalent structure. And then metallic bonding has one type of structure. What is the structure of metallic bonding?
Um, the positive metal ions are surrounded by the of the localized electron.
That is the definition of metallic bonding, not the structure.
Strong metallic.
Hmm. Strong metal. The structure is giant metallic structure. You still remember giant
No.
metallic structure? How does the structure usually explain? You explain it from the metallic bonding definition. Okay, and then
Okay.
okay, Natasha. Now the third one. Draw a labeled diagram to show the arrangement of particles in a crystal of nickel. The arrangement of a nickel crystal of nickel, just like uh, Natasha said before this, there is a positive ion that has a strong attractive force with the negative electron. So there is this one, okay, and then strong. There's this one positive ions. This is positive ion, and also this one is also positive ion, and around surrounded by electron. Okay, so this one is surrounded by electron, and then this one is called as the uh, at least six particles in each type. So you have to draw 6 times of this one. So mm, this one, two, and then 3, 4, 5, 6. So there is a plus here, there is a plus here, and there is a plus also. And then this one is electron, and then here electron, and then over here also electron. So the electron is surrounded the positive ion, and there is a strong attractive force between the positive ion and the electron. And then now next explain why nickel is ductile, can be stretched into wires. We studied already. Let me ask to Nathan V. Why is nickel ductile?
Nickel ductile because of the free numbers of electrons around it.
Mm-hmm. And
Yes. How many points do you want, sir?
nickel, because the electrons
Are free, are a lot that are free.
that is for conductivity,
Hmm.
not for the ductility.
Wait. It must be something with the bond. In
Yes.
extramolecular bond. Okay, so this is metallic bonding, right, sir?
Yes.
So metallic bonding allows it to be ductile
How?
because of the large number of uh, wait.
Because
Strong forces of attraction between the molecules. Uh, extramolecular forces that binds them is quite weak,
yes.
while the intramolecular forces are strong. The intermolecular forces are weak. Thus, it is ductile.
Oh, what is the intermolecular forces metallic in metal element?
It's metallic bonding, sir.
That is that is called as uh, metallic bonding. That is called as intramolecular forces, not intermolecular forces.
There is like
So
hydrogen bonding. Wait,
hydrogen
no,
bonding
no.
hydrogen bonding is intermolecular process, not intra. Intra, it is called as bonding. There are three basic bonding: ionic, covalent, and metallic bonding. And Nathan V, you mentioned about weak intermolecular forces, right? Weak intermolecular forces only occurs with covalent bonding compound or molecule. It does not uh, occur in metallic bonding and also in ionic bonding. So in explaining the ductility of nickel, we should not touch the word intermolecular forces because metals will not have intermolecular forces at all. It has only strong attractive forces that the particles can slide over each other. Okay,
Okay, sir.
okay,
Okay.
okay, Nathan V. Now, let me
Teacher,
ask. Yes,
can you please repeat it again
which one?
for a part 4
A. Oh, the
about the rise of
ductility.
the
The
yes.
ductility of nickel is because of the attractive force, between the particles. So and the particles able to slide over each other, but this sliding cannot make the particles to be broken. So instead of broken, it will become long structure, which is a
Mm,
long shape of object. It is called wire. So in metallic bonding, in metal, we never touch the theory of intermolecular forces because intermolecular forces only occurs with covalent bonding, and the covalent bonding, it must be a simple molecular structure. Okay,
thank you, teacher.
yeah, and also giant covalent structure. So we never connect metal with intermolecular forces. Later on, you will study in this semester. You will study about two different forces in a molecule, which is called as intramolecular forces and intermolecular forces. Okay. Now B. Nickel forms the compound nickel chloride. Give the full electronic configuration of nickel ion. Nickel ion Ni2 plus. Let me ask to Sharon. Sharon, nickel. Let us see the data booklet here. Nickel, nickel. Let's see nickel. Where is nickel? Oh, nickel is here. Nickel is having uh, nickel is having this one 28 electrons. Nickel is having 28 electrons. So Ni2 plus means the nickel has lost 2 electrons. Sharon, can you help us to make the electronic configuration of nickel?
Um, yeah.
Start from 1s2.
Um, wait.
Yes.
The 58 one or the 56 one?
Yeah, Ni is positive 2. Ni is positive 2. So Ni here is positive 2 ions. Positive 2 ions. So 1s2
1s2
yes, and then
s2 2s2
2s2 and then
p6
2p6 after that
3s2
3s2 yes, and then
3p6
3p6 and then
4s2 4s2 and
4s2
4p6
and then
3p6
3
p6
3d should be 3d, and then so the when it that you make the structure, the electronic configuration is nickel as an atom, not nickel as an ion. So it is 1s2 2s2 then 2p6 then 3s2 and then 3p6 and then directly 3d8 and then 4s become 0, or we can remove. Why is it like that? Because 4 here, the quantum number 4 is located in the outermost shell because it has the highest number of quantum. So highest quantum number, it means it is located in the outer part, in the outer part of the electron shell. Okay, Sharon. Now let's move to Timothy.
Teacher,
Yes.
I want to ask, when do we like follow the diagonal pattern, and when do we follow uh the front number?
Diagonal pattern.
Like why not for yeah? Why when do we follow the diagonal pattern?
Why do we have to follow? Because
When do we follow?
we have to follow every time when we are writing the electronic configuration.
So why not 4s goes first?
Because yeah, it is 4s, 4s, 3p6, 4s2, and then 3d8, right? Why is it not? Why is it become 4s0? Because 4, the quantum number of 4 is bigger than the quantum number 3. Quantum number represents the shell. So 4s means in the shell number 4. And then 3d means it is in the shell number 3. We know that the electron removed from an atom from the outermost shell, not from the innermost shell, and also not from the shell that contains the highest energy of the orbital. We know that 3D and 4S, they have similar energy level. 3D8 has similar energy level to the 4S, but 4S is located in the outermost shell compared to 3D. That is the reason.
Okay, thank you, teacher.
Yes.
Teacher,
Yes.
but does that mean for question number 1A for calcium, it ends with 3p6 and 4s2? So can we write it as 3p8 4s0?
3P8. Is that what you meant, Felicia?
Oh, wait, never mind. P only has 6. Oh, okay,
Yeah,
okay.
because the maximum of P is 6. We cannot make 8. If in the structure calcium 3p6 3D0 4s2. If we want to make the 3D appear, so 3D0. It doesn't contain any electron, so why do we have to write? So we can eliminate 3D0 in calcium.
Teacher, I have another question.
Yes.
The number of electrons of nickel is 28, right? But right now we're finding for nickel ion electron configuration. Right?
Yeah.
So the total number of electrons is 26. Um,
Oh, wait. This one is 10. 10 plus 8, 18. 18 plus 8,
Teacher,
18 plus 8, 26. Yeah, it's correct.
wait. I mean, like sometimes, like the first exercise that teacher gave us is like the 4S is like before 3D
Yeah.
because we follow the diagonal pattern.
Yeah, if we talk about the energy level, if we talk about the energy level, 4S has lower energy level than 3D.
Teacher.
But based on the shell, but based on the shell, 4S is located in the outermost shell than 3D. Okay.
When they ask for electron configuration, we follow the quantum number, but if energy level, we follow the diagonal pattern.
Yes.
Okay. Thank you,
Yeah.
teacher.
So, but we are not supposed to take the horizontal. We have to take the what's that? The diagonal. Okay.
Okay. Thank you, teacher.
Next. D2. B2. Balance the following equation. Balance the following equation. For this one, let me ask from Timothy. Hello, Timothy.
Hi, teacher.
Yeah. Uh, what is the balancing? This one. What is the coefficient for SOCl2?
SOCl2 in front there's 6.
Yes. And then NiCl2?
SL2 no 0.
Oh, no, it's not 0, it's 1.
Sorry. One.
1. And then in SO2, what is the
SO,
coefficient?
SO2 is 6
Yes. And then HCl?
of
Yes, correct. And then what is the substance? With both gaseous products. Gaseous products are SO2 and HCl.
The substance is NaOH.
Yes, correct. Sodium hydroxide can absorb. Okay, correct. And then now on the last page, last page, this one, oh, sorry, last page, on the last page. Here, let me ask let me ask, oh, what happened? Okay, let me ask from this one. Okay, let me ask, oh yeah, A, for number A, for this one. Let me ask after Timothy, T cell, T cell,
Yes, teacher.
yeah. Which of this one, which change requires largest amount of energy?
Is it A?
It is
A.
A.
It's A.
Okay. And then this one next, number six. Number six. Number six. Let me ask. Let me ask. After T cell, Vanessa. Which element is calcium, Vanessa?
Is it Y?
Is it Y or X? Y. Correct.
Y.
Yeah. Y is calcium. Why is it Y? Why not X? Because there is a huge jump in Y. There's a huge jump between the second to the third. There's the reason. And then Vedica. Which element is vanadium?
Yes, teacher.
Yeah. Which element is vanadium? X, Y, or Z?
X. X.
X. Why is it X?
I'm not sure, but I think it's X because
Because there is a huge jump. Vanadium, vanadium is V2 huge jump between the between the fifth and the sixth. We know that vanadium oxide in the contact process, vanadium oxide V5 positive. So positive 5. So it means there are 5 electrons in the outermost shell. Okay, and then now, uh, yeah, that's correct, because in the fifth, between fifth and sixth, in X is the highest jump. Okay, so these are the review for today, preparation for tomorrow test. Okay, if you have any question, you can ask me on the Google Classroom, or you can ask me on other day, but not tomorrow during the test. Okay, good afternoon, students. So you may leave and have your
teacher.
lunch.
Thank you.
Yes, thank you.
Yes, you're welcome.
Thank you, teacher.
Thank you,
You.
teacher.